Okay, so now we're actually going to get into actually finishing the whole entire problem. We're going to be adding and subtracting rational expressions. So the first thing that we're going to do is we're going to find the least common denominator. We just practiced that. The second thing, we're going to write the equivalent fractions. We had a little bit of practice last week with that. Then we're going to actually finish the problem, okay? So let's look at number 1. And as I said before, you've got to make sure that you treat monomials and binomials differently, okay? So number 1, does this have a common denominator? No, it does not, unfortunately, okay? So what we're going to have to do is we're going to have to find the LCD. So I'm going to make some space somewhere underneath here. So I need to figure out what I have in common, what I have not in common. Now you can do this part in your head if you're really good at it, but I'm going to write it down for your notes. That way you can see what we're doing when you come back and look at your notes. So since these are monomials, okay, monomials, you're going to look at the 4 and the x separately. Now you can break down the 4 into 2 times 2, but I'm not going to do it because the other one's a 5. There's absolutely nothing in common between any of these things. So there's nothing in common. I'm going to put NA here. I'm just going to ignore that. And I have everything else not in common. So basically you got a 4x and you have a 5. So to find your LCD, you multiply everything together. So 4x times 5 gives you 20x. So your least common denominator should be 20x. Okay, now if you want to get out a different sheet of paper, there's not a lot of room on your notes. I'll give you some time to do that. I'm going to do this. I'm going to rewrite it. Okay, so I'm going to put 5 over 4x equals, and then I'm going to do x over 5 equals. We need to write equivalent expressions. So I want this to be 20x, correct? And I want this one to also be 20x. So what we need to do is we need to figure out what each fraction needs to write the equivalent fraction. So it looks like I already have an x here, but the 4 needs to become a 20. So I would multiply that by 5, correct? So what I do to the denominator, I also need to do to the numerator. So I'm going to multiply the top by 5. You do need to simplify the top. So 5 times 5 is going to give me 25. Now that's going to not be simplified, and that's okay because it's an equivalent fraction. That's just the way it is. So what do I need for the bottom one? I need a 4, and I also need an x. So I'm going to do the same thing to the top. When I multiply x times 4x, I get 4x squared. Okay, so that's my second step. Now I'm going to rewrite the problem. So this is a subtraction problem. So I'm going to do 25 over 20x minus 4x squared over 20x. Now that looks much better. So as long as I have a common denominator, I'm going to go ahead and add or subtract across the top only. So I'm going to put 25 minus 4x squared over 20x. Now, your very last step is that you've got to figure out if you can possibly factor the top. And you know what? I recognize the top as a difference of squares. Do you see it? Okay. Now, I know, because I have a lot of experience with these problems, I know it's not going to help me if I do it, but I want to show you. So you just watch what I do. So this is a difference of squares. That's 5 plus 2x and 5 minus 2x. Now you see how that factors into binomials in the numerator? They're binomials, but your denominator is a monomial. Can you cancel a binomial with a monomial? No, you cannot, okay? So just make sure, even if it's factorable at the top, if I can't simplify it later on, I'm not even going to bother with it. So final answer, that's it, okay? All right, let's look at the second one. So like I did before, the 2x, it doesn't have a denominator, so I'm just going to put it over 1. There's really nothing going to be in common if you have a denominator of 1, so I'm just going to use 5x to the third. as my LCD because there's nothing in common. So let me write that down. So my LCD is going to be 5x to the third. So I'm going to come over here and I'm going to create an equivalent fraction. So I have 2x over 1, but I want it to be 5x to the third. Now, do I need to modify the second fraction if it already has 5x to the third? Absolutely not. So I'm just going to leave it alone. Okay, so what do I need to make it 5x to the third? I need all of it. So I'm going to have to multiply the bottom times 5x to the third, and I'm going to have to do the top, 5x to the third. Probably should have left myself some more space. So let's do that. Okay, so now I have 5x to the third. On the top, they are monomials, okay? Monomials. So when you're multiplying monomials, numbers first. So 2 times 5 gives you 10. And then x times x to the third would be x to the fourth because you have to add your exponents. Okay, so I'm going to rewrite the statement. I'm going to put 10x to the fourth over 5x to the third plus 3 over 5x to the third. Awesome. So as soon as I have the common denominator, I'm going to go ahead and do what it tells me to do. This time it's adding. And I'm just going to add across. Can I add these two terms together? Absolutely not. They are not like terms. And as tempting as it may be, you need to be aware that the top is a binomial. The top is a binomial that you can't factor. The bottom is a monomial. Are you able to take these and cancel them? Absolutely not. Are you able to take this 5 and reduce it with this 10? Absolutely not. So if the numerator is a binomial, you cannot separate certain parts of that binomial to cancel it out with the monomial underneath, okay? We're done. Next one. So does this one have a common denominator? It does. So I don't need to find an LCD. I already have it. Do I need to write equivalent fractions? Nope. So I'm going to go directly into the subtraction part of it. It is subtraction though, so you're going to have to be very, very careful how you write this out. So I'm not subtracting 6x minus 7. Well, I guess it's kind of. So I've got 6x minus 7, okay? So I'm going to write 6x minus 7. I am subtracting all of the second numerator. I'm subtracting all of that binomial. So I'm going to temporarily put this in parentheses, okay? And keep my denominator of 4. We're writing it like this in your notes so you can visually see why your signs are going to change. So I'm subtracting a negative 7. So if I subtract a negative 7, that turns into plus 7x. And I'm also subtracting negative 9. So if I subtract negative 9, that's going to be plus 9. Then continue. That's like the number 1. And it gets honors kids, it gets regular kids, it gets everybody. So be really careful when you have subtraction and you're subtracting more than one term. So I'm going to add my like terms together. I have 6x and 7x, 13x, and then I have a negative 7 and a positive 9, which is plus 2 over 4. Now, remember, the top part is a binomial. It is not factorable. So I don't have a GCF. I can't separate it at all. So that 2 and that 4 are off limits. So monomials cancel with monomials, binomials cancel with binomials. So we're done. Okay, you guys ready to try one? Okay. I'm going to pause the video and I'm going to actually check back in with you with the LCD, okay? Okay, so I have this denominator factored, and what I have in common, so I'm going to write LCD here, I have an x plus 6 in common, and I have an x minus 7 not in common, so you would multiply those two together. Since they're binomials, leave them unfactored. Leave them unfactored. Now, let's talk about equivalent fractions. Do I need to change the first fraction? Yes. So I have 7 over x plus 6, and I want it to have a denominator of x plus 6 and x minus 7. Now, do I need to change the second fraction? Absolutely not. It doesn't matter what order that is in, so it says x minus 7, x plus 6. It's the same as x plus 6 times x minus 7. So I'm only going to change the first fraction. What do I need to make x plus 6 into the LCD? I need an x minus 7, right? So I'm going to multiply that times x minus 7. See how I keep that in parentheses? Because it's a binomial. You need to treat that as a group. So as I simplify the numerator, I need to distribute the 7. So 7 times x is 7x. 7 times negative 7 is negative 49. So I'm going to rewrite my problem. So I've got 7x minus 49 over my LCD. Okay, this is a subtraction problem, but I didn't need to change it. I just have that one term on the top. Okay, so now that I have equivalent denominators or the same denominator, I'm going to subtract across. So I have 7x minus 49 minus x, and then keep your denominator. And then add like terms. So you have 7x minus x is 6x minus 49. And then I have x plus 6. And then I have x minus 7. Then you just have to stop and you got to look at it and you're like, can I factor the top? No. Even if I had a GCF, I wouldn't be able to cancel it with anything in the denominator because those are binomials. I might have leftovers the same, but I don't. So I'm done. So number 5 is special. It's going to figure out if you know a very specific factoring technique. So what do you guys notice about this denominator and this denominator? They're like the same, but not the same, right? Like, what's different? Okay, you notice how they have the same terms except for their signs are exactly the opposite? So like you have a negative 3 in the first one, but you have a positive 3 in the second. You have a positive x in the first, but you have a negative x in the second one. If you see that pattern, okay, if you have exactly the same terms, but one of them is the opposite sign, this is how you deal, okay? You're going to factor a negative 1. So take out a greatest common factor of negative 1 and watch what happens. You actually wind up with a negative 3 plus x, but if you use the commutative property and you rearrange that, you actually wind up with x minus 3, don't you? So I have something that is equivalent. I didn't change the value. I used a technique. So if you see that pattern, factor out a negative 1. It really doesn't matter which one you do. That one's probably the best one. I'm going to get rid of this because I don't want to see it anymore, okay? Now, LCD time. What do I have in common? I have x minus 3 in common. What do I not have in common? The negative 1. I don't have the negative 1 in common. So if I took those and I combined them, my LCD is going to be negative 1 times x minus 3. So I'm going to write that down. So my LCD is negative 1 times x minus 3. Leave it factored. Leave it factored. Okay, so let's talk about equivalent fractions. What do I need to change? The second one already has the appropriate denominator, so I just need to modify the first one. So I'm going to write down 5x plus 2 over x minus 3. and I want it to just have a -1, right? So I'm going to have to multiply the bottom by -1, and I have to multiply the top by -1. And this really hasn't happened yet, but you notice how the top is a binomial. So if the top is a binomial and you're multiplying by -1, that means you will have to distribute the -1. So the whole entire numerator needs to be multiplied times -1. So I get -5x minus 2. Okay, so now I'm ready to rewrite it. So that was my first one. And then my second one had no change. That was minus 2. Now that's kind of a little weird. We got that little -1 hanging out right there, okay? Here we go. Okay, so now that I have a common denominator, I'm going to write -1 and then x minus 3, and then I'm going to do what it tells me to do. I've got -5x minus 2 and then minus 2. I have a couple of like terms right here. So that means I have a -5x minus 4 on the top. And then I have a -1 and then x minus 3 here. If you are doing this with Delta Math, I think this is what it's going to want you to do, okay? In general, it is not accepted to have a negative denominator, but then I've got that -1 staring me in the face right now, okay? So let me tell you how to deal with that. So this one problem is like how to deal with lots of different little things. All you do is you take this -1, that -1 will float to the top. It doesn't matter because -1 in the denominator is the same thing as -1 in the numerator, okay? So what we're going to do is this. We're going to multiply everything on the top by the -1. What's going to happen to the signs? They're just going to change. So that's going to be positive 5x plus 4 over x minus 3. That is what they are going to want you to answer on your ACT, on Delta Math, or whatever that we use, okay? Now, I can justify that. I can justify that because if you factor out a -1 in the top also, please don't write this down. Watch what happens. Guess what cancels out? What's -1 divided by -1? They cancel out, and guess what? That's what you're left with, okay? So you can justify it using factoring. Okay, I've got one more, and this one I kind of want you to do completely on your own. So I'm going to pause this video, and then you're going to put your answer on the dry erase board. So here's what we got here. We have absolutely nothing in common, so your LCT is going to be x minus 6. So I only need to write one equivalent fraction, that's the 5. So I came over here, and I needed to adjust it by multiplying the top and the bottom by x minus 6. And then I distributed the 5 here. And you've got to be super careful when you're subtracting. So when you rewrite it, make sure you're subtracting 2x and you're subtracting 5. And then if you just add these together, you get 3. And then you add these together, you get -35. And there's nothing that you can factor on the top. And that's pretty much it. So good job.